Okay, so now we're going to go over the remainder of the basic assumptions. The basic assumptions for independent groups t-test is that the dependent variable must be at least interval level of measurement. That means we need that to be parametric. The independent variable must be nominal or ordinal in nature and must classify subjects into separate categories or groups. It's that separate categories or groups component that turns it into independent observations or independent groups t-test. And then finally, dependent variable scores should be essentially normally distributed. The essentially normally distributed comes from the essential limit theorem. This is often violated, but it is a basic assumption. Ideally, we'd like similar sample sizes in each of these groups, so we'd like to compare 20 males to 20 females or 18 males to 16 females as opposed to 10 males to 40 females. Subjects should be randomly selected. Again, this comes from the concept of the central limit theorem, where we want people to be coming from, we would like them to be as representative of the sample as possible. And this final part is the major component that we need to go over, which is called the assumption of homogeneity of variance. Here are the variances, and remember we learned variance in the last lecture, talking about variability in units squared. The variability of the dependent variable scores, so that's your y-scores, must be essentially similar across both levels of the independent variable. We're going to spend the next couple of slides talking about that. This assumption states that the variances of the dependent variable must be essentially similar across both levels. It does not imply that those variances both must be normal. One could be leptokurtic and the other mesokurtic. One could be leptokurtic and the other leptokurtic. They could both be mesokurtic. They could both be platykurtic. But remember, what we're talking about here is we talked about in that last lecture looking at variability or variances. That's the distance around the mean. So we want those distances for males and the distance for females to be essentially equal. And that's what we're going to test for when we test for the assumption of homogeneity of variance. So, as I was saying, homogeneity of variance implies that if the distribution for males is leptokurtic, then for females it's also leptokurtic. If the distribution for males is platykurtic, then for females it should also be platykurtic. If the distribution for males is mesokurtic, then the distribution for females should also be mesokurtic. So, I don't know, I got cut off because I accidentally closed it, so I don't know how much was recorded that I said here, but you could have both distributions be leptokurtic, both be mesokurtic, or both distributions be platykurtic. And you can see an example of that in this example. So here, unfortunately, my bell curves got cut off in this app. If you go to the slides, it should come out a little nicer. Here's my y variable, which we know is GPA. Here are my two distributions, and the variances are the distances that make up these distributions, that width. And we can see if we look at them, those widths are essentially equal. So that would tell us that we probably have a homogeneous variance. Notice I could care less at this point about where the means fall. We'll test the means later. We're not doing our hypothesis testing yet. Now we're just looking at the variances. If we have heterogeneity, this is where you might mix two different types of distributions. So you could have a leptokurtic distribution for males and a mesokurtic for females, a platykurtic for males and a mesokurtic for females, a leptokurtic for males, a platykurtic for females, or some other mismatch. So an image for that, if you take a look, we could have a much more peaked distribution here, where we have a much more spread out distribution for here. So you see this is a lot tighter than this. And that would suggest that we probably have a heterogeneous distribution. Now, I will tell you, you're not going to have to eyeball this. We actually have a statistic that you can tell to determine whether or not we've met the assumption of homogeneity of variance or not. So a separate hypothesis test is done to determine if the researcher has met or violated the assumption. This has nothing to do, this hypothesis test for the assumption of homogeneity of variance has nothing to do with the hypothesis about our GPA of males and females. So this has nothing to do with means. It's only testing variances, or what we always called sigma. The conclusion from this separate hypothesis determines how our t-test is calculated. If we meet the assumption, like we are going to do in assignment 1, then you're going to have to do one formula. If you violate the assumption, there is a separate formula to calculate t. So the test that's reported on your SPSS output and is called the Levene's test of equality of variance is the test that we're going to use to determine if you've met this assumption. To report the results of this test, you're going to apply the appropriate procedures for interpreting significance. Alpha is predetermined value set by the researcher. Significance, the p or two-tailed sig, is the actual error that we do. We're going to compare p to alpha. So to interpret the significance, if p is greater than alpha, then error is too high, and we're going to say that no differences exist. So you accept the null hypothesis. Well, in this situation, we don't want differences to exist. We want homogeneity of variance. So we actually want, in this situation, to see p be greater than alpha. If p is less than alpha, that's going to suggest that our error is low, and we're going to have to reject the null hypothesis, saying that our variances are different. So if we take a look at the SPSS that you're going to see this are two components. This, to the left, this is your Levene's test, testing your homogeneity of variance. To the right is your t-test. Think of them as two separate tables. Do read them completely separately. I don't like that SPSS combines them. They give you an F value. We'll talk about F values later this semester, but what you're reading is the sig value. If that sig is greater than 0.05, then you can accept the null hypothesis and say that our variances are similar. If that sig is less than 0.05, then you have to say that our variances are different. So for this assignment for your assumption of homogeneity of variance, be sure to do the following: state the hypothesis symbolic form, write a statement of the finding for the Levene's test, write a conclusion statement that tells you whether or not you met or violated the assumption. Make sure to complete all of these elements for both part 1, number 1, and number 2 of this assignment. Also make sure that in number 1 you meet the assumption, and number 2 you violated the assumption. We're going to talk about how to make those data sets when I come back to class. I'm just going to start you off with a theory now. Actually, I should really show you how to make the data sets, just so that you can see it out. When you need to make the data sets, you can get started on this homework. To meet the assumption, you want to make sure that the data have similar ranges. To violate it, you want to have one range be a lot farther than the other. That's going to change the variability. To give you an example, here are the two I'm going to be using in this homework, or in this lecture. On the left, you see that the ranges are relatively similar. They range, the lowest score is 2.3, let's see if I can put here, 2.3, and the highest score for males is 3.1, so the largest range there is about 0.8, or 0.8 of a point. For females, the lowest score is 3.0, the highest score is 3.9, so we have 0.9 of a point, so relatively similar variability or ranges. On the right side, when we violate the assumption, notice for athletes the lowest score is 2.1, the highest score is 3.9. We have 2.8 differences. 2.8 as our difference or our variability, where we have a much closer variability for non-athletes. They only range from a 2.9 to a 3.5. 0.6 is our difference. So in here, we're going to meet the assumption. Over to the right, we're going to violate. Go ahead and get your data set up for your homework, and that should help you get going for when I see you back in class.